Hello biologists. In today's video I'm going to explain how to calculate the rate of reaction from a graph. This is normally a skill that students find really difficult, but it's very common and it comes up mainly with enzyme type of questions in your Year 12 learning, which you may have already learned if you've just started A-levels. So I've got a graph here. On my y-axis the volume of product produced and on my x-axis the time. I'm going to calculate the rate of reaction at 5 seconds and then at 10. The key to calculating rate of reactions is remembering what you've learned in maths. The gradient of a line in this context tells you the rate of reaction. So for 5 seconds, I'm going to use a ruler, which you would be doing if you're doing this on paper. I'm going to put a mark at 5 seconds and draw a tangent line. Now, as we can see, this part of the graph is straight, which makes life very easy because my tangent line is just going along the line of the graph. You then make your tangent line into a triangle. Try to make your triangle as large as possible, not a tiny little triangle. And ideally, choose some numbers that you will be able to read from your graph. So this line is called my tangent. And I'm going to read the numbers from the y-axis and then divide them by the numbers from the x-axis. So my y-axis value is 40. I subtract that from the y-axis value at the bottom of my triangle, which is 0. I'm going to divide this by the values from the x-axis. So my x-axis value is 10. And at the start of the triangle, it's 0. So that is going to be 10 take away 0. 40 divided by 10, giving me a rate of reaction of 4. But what are the units? Well, this is where the graph can help us. Centimetre cubed per second. Now that example is quite nice because the 5-second point coincided with a straight line linear section of the graph. But if that's not the case, we still follow the same method. We draw a tangent line. So now I'm going to go to 10 seconds. I'll remove my first triangle so that there's a bit less confusion. And now I'm going to do a tangent line at 10. So I'm going to do a dotted line to go up to 10 seconds. Using your ruler, you draw a tangent line, your straight line, and then you're going to turn it into a triangle, just like we did before. It doesn't matter if you do your triangle going underneath like that. It doesn't matter. You're still going to get the same answer. But what is important, you need to have approximately the same space in this gap. And that part students find really tricky. So you have to move your ruler around to try and get equal space on either side of your tangent line. We're then going to do, again, the same principle of reading from the y-axis. My 2 points I'm going to estimate are 50 and I'm going to say 22, the bottom of my triangle there. Divided by, if I go to my x-axis, I haven't chosen very nice numbers this time, but it will still work. I'm going to say 17.5, take away 0, because that's the beginning of my triangle on the y-axis. So I won't be able to do this one in my head. This one's going to require a calculator. So 50 minus 22 is giving us 28. And then I'm going to do 28 divided by 17.5. You might have got the answer before I have. Gives us 1.6. The units are the same, centimetre cubed per second. What does this information tell us though? We know that the rate of reaction was higher at 5 seconds compared to 10 seconds because 4 is a bigger number than 1.6. Another way we would know that the rate of reaction is higher at 5 seconds is because the gradient of the line is steeper at 5 seconds compared to 10 seconds. At 10 seconds, the graph is starting to level off. If this is an enzymes question, you're talking about all of the substrate being used up, or the substrate is being used up, so there are fewer enzyme substrate complexes, making your rate of reaction slower. I hope you found this video helpful and you understand how to calculate rate of reaction. And if there are any other specific topics you need help with, leave a comment and I will make a video about it. Bye.